Assalamu alaikum. Welcome to the GFC school. Guys, this is Muhammad Gyasuddin. Now, I am gonna to discuss gravitational field, and you can see this peak here. What do you mean by this peak? It's a solar system. It's sun. Around the sun, different types of planets are rotating, such as Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. How do they rotate around the sun? Can you say? Could you say me the answer? Why are they rotating around the sun? Why they are not falling towards the sun, or why they are not going outward of this orbit? What's the reason behind that? It's my question. Could you tell me? Anyway, let me explain. Actually, it's a force, gravitational force. Okay, and that picture you could see. Look, here the plane is flying. This is gravity, downward force. This is another picture where we can see sun and earth are attracting each other. Okay, this is the attraction force of Earth. This is the attraction force of earth towards the sun. This is the attraction force of sun. This force we have to understand, and for understanding this gravitational force, laws of gravity, we have to know, and we have to know this formula for GM. I will explain this. Just you try to feel what I'm gonna discuss. Okay, what I'm going to discuss, you try to feel from this figure. Okay, guys, another picture, try to understand. Another picture, this is a picture, and world is in the gravitational field, gravitational force. Anyway, this explains less. And another picture, you can see from this picture you may understand gravity force. Here ball is falling down, apple is falling down, and this baby is flying, but downward force is acting by the earth. This is actually force, gravitational force or gravity force, which we are going to learn. Okay, and the picture you can see from this picture, you may feel the force between earth and the satellite. Guys, this is satellite, and satellite is in rotation surrounding the earth. It is earth. Okay, you know, there are a lot of satellite, artificial satellite, which are rotating around the earth. Okay, and you know, our Bangladesh 5 years ago sent Bangabandhu satellite. That satellite is rotating with respect to. Look at another picture. What do you mean by this? Okay, fine. Now now we will understand gravitational field. What is gravitational field? Look, gravitational field is a gravitational field in a region of space where a mass experiences a non-contact gravitational force. Is a region. That is a region of space where a mass experiences a non-contact gravitational force. Guys, if you think about my previous pictures which I shown you, that then you can understand actually what do you mean by gravitational field region. Suppose this is earth. Okay, it's earth. Okay, and field means surrounding this earth, this region, this area. In this area, something is attracted by this earth. Okay, something is attracted. Suppose I show you satellite. A satellite is rotating around the sun, so there is a attraction force between satellite and earth. That is actually this region is gravitational field. This region here, this body. Try to change my color, but here any body or satellite will not be attracted by the earth. That's why we won't say this is a field. We'll say this area is field. Okay, space where mass experiences a non-contact gravitational force. Guys, it's a non-contact force because on body doesn't touch another body for feeling something. Okay, understand? Non-contact force. Some force are contact force and some force are non-contact. Gravitational force is non-contact force, and electrical force non-contact force, magnetic force non-contact force. Non-contact, that means there is no option of touch. Okay, for feeling this force, no necessity to touch anything. Okay, from a separation, from a distance on body is attracted by, suppose this satellite. Okay, last picture I showed you satellite. And okay, let me show this picture again. This satellite, non-contact force. Here, this satellite, this satellite, and this is Earth. There is a separation, so it's a non-contact force. There is no touch. The satellite doesn't touch the Earth, or Earth doesn't touch the satellite, even though there is a force of attraction. That is called non-contact force. Okay, fine. Okay, now gravitational force we have understood. Gravitational field means a region of a space where a mass experiences a non-contact gravitational force. Now, types of force fields. Force fields are created. When certain object interact. Gravitational force interaction of masses. Due to masses, we can see gravitational field, guys, and due to charges we can see electric field. Next chapter we'll understand electric field interaction. Okay, and magnetic field interaction. For moving charge we'll get a gravitational field, magnetic field. Here, magnetic field, we'll learn this next chapter. Therefore, gravitational field is a reason why any object with mass feels a gravitational force. This line try to remember. Okay, now types of gravitational field. Uniform field, uniform field. Look at this picture. This is uniform magnetic field because this line equally spaced. That means gap same. Okay, look at this. This is non-uniform magnetic field. Why? Non-magnetic. This line has gone along this. This line gone has another half hazard. That's why they are non-uniform. Gravitational force is the same everywhere. Then we'll say this is uniform field. Okay, field lines are parallel. Look, this is parallel, and equally spaced. Here, space, equally separated. That's why it is called uniform field, and it's not okay. Now, radial field. Radial field actually, radial field means circular. Like look, gravitational force depends on the distance from the center. Gravitational force depends on the center. With respect to center, gravitational force we will get. That is actually radial. Look here, radial. This is a radial system. It's a gravitational force depending on the distance from the center. This is the Earth, and the Earth has a center. From the center, we could see this is the force of line. This is the force of line. This is the force line. This is the force of line. This is the force of. That is radial, not parallel. This is radial. That's why it is called gravitational force. Gravitational force depends on the distance from the center. Field lines spread out from a point. From a point. Suppose this is circle center. Okay, from center, from this center, this force are concentrating or spreading. Okay, and that is why it is radial field. Okay, now try to understand the field line meaning. Field line meaning. Now we'll understand field line meaning. Arrow show the direction. Look, direction. This is what we have to understand. Arrows means this is arrow. Look, this arrow is meaning the direction of the lines of force. Closer field lines, where here this is what closer. Okay, this is very close to, or here. These lines are so close. Okay, so then we'll say stronger gravitational field. Here we could say stronger gravitational field. Here we could say stronger gravitational field. Very close to Earth's surface. The field is almost uniform. Very close to. That means here, these, they are uniform. But if you go here, they are not uniform. Okay, farther away it becomes radial, guys. Farther, then we will see radial. Not like this, not like a parallel. We won't see like this is parallel, this is parallel, this is parallel. But farther we can see radial. Radial means, look, radial means here such type we could see radial. Okay, now we'll understand gravitational field strength. Guys, look at this word, strength. What do you mean by strength? And we use the symbol due to strength, small g. Okay, arrow show the direction of the. Okay, that's gravitational field strength formula. This second one. Okay, this is gravitational force. This is F. This is mass, and this is force, and this is gravitational field strength. Gravitational field strength at a point, Newton per kg. Gravitational force on a small object, Newton. You know the unit of force, Newton, and unit of mass, kg. That's why gravitational field strength unit, Newton per kg, and mass is a small object. Guys, what do we understand from this formula? And you know all from where have we got this formula? Each and everybody know F equals mg. This is actually weight. Okay, and from this formula we are very known to this calculation, F equal to mg. That's why we could write G equal to F upon m. Okay, simply we can find out the gravitational field strength. suppose an object mass 5 kg, okay, and it has placed in a gravitational field which force is 10 Newton. Then what we will say the gravitational field strength? We could say very simply here, F means 10, F means 5, that means 2 Newton kg. Okay, Newton kg, Newton kg. You could simply say Newton kg minus 1. Okay, that means G equals 2 Newton kg minus square. Okay, this is the amount of gravitational field strength, guys. Okay, that's all today. Before finishing the class, I could show some formula, circular formula. This formula will understand, and gravitational force will get this formula. Okay, we'll get this formula we'll use. Okay, we'll use this formula, and electric field will know about electric field. We'll know electromagnetism. We'll know electromagnetism. This formula will know. Okay, and C theory will know, and we'll know quantum physics. We'll know nuclear physics. Guys, that's all today.